Special angles refer to certain angles for which we can know the exact values for sine, cosine, and tangent. So what are these special angles? Well, most of the time when people say special angles, they're talking about 45-degree angles, 30-degree angles, and 60-degree angles. In order to remember what the sine, cosine, and tangent are for these special angles, we can draw diagrams called special triangles. If you draw a right triangle with a 45-degree angle in it, that means the other angle has to be 45 degrees as well. This makes it an isosceles triangle, so this side and this side have the same length. I'm just labeling them with a length of 1 for simplicity's sake. If you then do the Pythagorean theorem to calculate the length of the hypotenuse, you'll end up with a length of the square root of 2. That's the exact length. I can draw another right triangle with a 30-degree angle in it. That means the other angle has to be 60 degrees. If I make my shortest side 1, shortest side is across from the smallest angle, and my longest side 2, hypotenuse is always the longest side, I can do Pythagorean theorem to calculate the length of my other side, and I'll find that it's the square root of 3. That's the exact length. So these are called the special triangles, and you'll see that they involve the special angles listed above, 45 degrees, 30 degrees, and 60 degrees. I can use these triangles to figure out exact values for sine, cosine, and tangent. If I look at my first special triangle, I can see that the sine of 45 degrees is 1 over root 2. I'm just saying sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so it's 1 over root 2. The tangent is opposite over adjacent, so it's 1 over 1. I can simplify that to just 1. So those are the exact values for the sine, cosine, and tangent of 45 degrees. I can do the same thing for my other special angles, just using the other special triangle that I drew. I can see that the sine, cosine, and tangent of 30 are these exact values. And I can use the same triangle to calculate sine, cosine, and tangent of 60 degrees. You don't have to necessarily memorize these special angles and their sine, cosine, and tangent, but if you know how to draw the diagrams of the special triangles, then you can figure them out. It's good to know these special angles in case you're asked to find exact values. So here I have two expressions, and I'm asked to find the exact values for them. For this first one, sine 45 times cos 60 times tan 30, well, those are all special angles. I just figured out that the sine of 45 degrees is 1 over root 2. And I already know that the cosine of 60 degrees is 1 over 2. And the tangent of 30 degrees was 1 over root 3. So those are all exact values. If I multiply them together, I'll get my exact answer. If you multiply the numerators together, you get 1. If you multiply the denominators together, you get 2 root 2 root 3. And that simplifies to 1 over 2 times the square root of 6. I'm not going to plug that into my calculator because I won't get an exact answer. And this question's asking for exact values. If I look at my next question, I can do the same thing. I know the tangent of 45 is 1, the sine of 30 is 1 over 2, and the cosine of 30 is root 3 over 2. When I multiply those together, I get the square root of 3 divided by 4, and that's my exact answer.